Aloha everybody, this is Gigi from Kauai Community College. This is a video on limit at infinity and how it relates to the horizontal asymptote. For this particular example though, we will have no horizontal asymptote. Instead, we will have what we call a slant asymptote. So let's see what that is all about. Okay, so if you have the function f of x is equal to 3x squared plus 3x to the third plus 6x squared minus 2x, all divided by x squared minus 1. If this is our function right here, okay, and we're studying the horizontal asymptote, when studying the horizontal asymptote, the definition of horizontal asymptote said the limit as x goes to infinity from the left or from the right, meaning all the way, all the way to the right, maybe meaning positive infinity, or all the way to the left at negative infinity of f of x, if that limit at infinity is equal to some number, then the line y equals L is a horizontal asymptote, right? So in this problem, while searching for that horizontal asymptote, we are looking at what is the limit at x goes to infinity of 3x to the third plus 6x squared minus 2, all divided by x squared minus 1. Okay, let's go ahead and do a little thinking here. So here's my little thinking bubble. If I divide everything by x to the third, okay, then I will have 3 on the numerator plus 6 over x minus 2 over x to the third, all divided by 1 over x to the just x minus 1 over x to the third. But what's going to happen when we do that is these are going to 0 when we take the limit as x goes to infinity, which is really not helpful. We cannot determine what that is, except for that this right here is going to be really small. So this right here is going to be really big, right? So it's not equal to L, and if it's not equal to L, then what is it? So another idea is to go ahead and divide everything by x squared. And if we do that, we would get 3x plus 6 minus 2 over x to the third, all divided by x. There's no x anymore. We're dividing by x to the second power, so we'll have 1 minus 1 over x squared. Okay, so then this is when you take the limit as x goes to infinity. This goes to 0, right? 1 over x will go to 0. 1 over x squared will go to 0. And then 2 over x to the third will go to 0. Okay? So what we have left is just 3x plus 6. So what we are saying is when x is going to infinity, this function right here is going to behave like 3x plus 6. And 3x plus 6 is a line. So when x is approaching infinity, the limit as x goes to infinity of f of x, then your function is going to infinity as we have seen, right? When x is big, then 3x plus 6 is going to be really big. And then the limit as x goes to negative infinity of f of x is going to be a really negative number, which is negative infinity. So your function is going to behave like the line 3x plus 6. So you don't have a horizontal asymptote. Here you have a slant asymptote, a diagonal, a linear, a line as your asymptote. Now, sometimes people will tell you to go ahead and do a long division. And I'll show you why we would want to do a long division for this. Okay, so again, our function is 3x to the third plus 6x minus 2, all divided by x squared minus 1. And we were interested in the limit as x goes to infinity. What happened, right? So another thought is to go ahead and use long division. So when you use long division, this will happen. You will have 3x to the third plus 6x squared minus 2, and that right here should have been a square, okay? And we are dividing that by x squared minus 1. When we divide, we will have 3x to the third divided by x squared is going to give us 3x. And then we would multiply, and then we would subtract. That's how we would do long division. So when we multiply, we'll have 3x to the third minus 3x. And then we're going to subtract. When we go and subtract, this signs will change. So we will have, this is gone, 6x squared stays 6x squared plus 3x minus 2 as our remainder there. And we keep proceeding. So 6x squared divided by x squared is going to be 6. Then we multiply, we'll get 6x squared minus 6x. And then what are we going to do there? We are going to subtract because that's how we do long division. And when that subtraction happens, the negative 6x become a positive 6x because you are subtracting a negative. This is gone. We'll have 9x minus 2 as our remainder. 9x minus 2 as our remainder, right? So question here is how does that relate to what we were doing earlier? This fraction that we are looking at now becomes limit as x goes to infinity of 3x plus 6 plus, and how do we write the remainder? We write the remainder over what this is that we were dividing by. So on the numerator, I will have 9x minus 2 divided by x squared minus 1. Okay, so when you are taking the limit of this whole entire expression here, you will see then that this will go to 0. Okay, because what we're going to do is we're going to divide everything by x squared. So on the numerator, you will have 0, and on the denominator, you will have 1. So that equals to 0, right? And then so again, our limit then just becomes 3x plus 6. And that is a line, it's linear. So what we are saying again is that we are having a slant asymptote. And that slant asymptote is 3x plus 6. In other words, our function is behaving like this line when x is approaching infinity or negative infinity. Way out there, on the right-hand side, your function is going to follow this line. And then again, way out there on the left-hand side, our function will also follow this line because that is a line where the y-intercept is 6 and the slope is 3. So that's a line that looks like this, right? 3x minus 6. So our function is kind of behaving like this over there and then behaving like this over here, way to the left and way to the right. Okay, so that is what a slant asymptote is. A slant asymptote is when you are looking for the limit as x goes to infinity, meaning when you're studying that horizontal asymptote, you'll get a linear function. That's a line. So you are saying that your function way out there will behave like that line. And you can use long division to show your work here, or you can say take the limit as x goes to infinity, but instead of dividing by the highest power, you'll divide by the highest power that is on the denominator, like this one right here, and you will see that that is going to give you 3x minus 6. Okay, so two different ways to look at it, whatever you like. I think most textbooks will tell you to do a long division because that is a little bit clearer to say that this fraction right here, that is going to go to 0. But up to you how your brain works, okay? And that is what a slant asymptote is. Now, does it have to be a line? Could it be something like a quadratic? In which case, we wouldn't call that a slant asymptote, right? We would say that the function will behave like a parabola. For example, f of x is equal to, and let's think about that for a second. When is it that you will get a function that behaves like a parabola? So instead of 3x squared, let's say 3x to the 5th plus 6x to the 3rd minus 2 divided by x to the 3rd minus 1. So do you see what happened here when you are dividing something to the 5th power divided by something to the 3rd? Your function would be approximately 3x squared something. So your function, when x goes to infinity, when x goes to positive or negative infinity, your function is going to behave like a parabola. And which one is it? It's that one. And how do you find it? Use long division. Okay, so hope that clears up a little bit of what might happen when you are looking for the horizontal asymptote. When you're looking for the horizontal asymptote, instead of x equals to L and you get a horizontal asymptote, if it doesn't come out to be a constant number, meaning a horizontal line, then you may get a slant asymptote, which is linear. And how do you find that line? You use long division. Okay. Or you might get something that is like a parabola. And how do you find that parabola that your function behaves like? You would go ahead and do long division.